Good morning, everyone. So these videos are going to be largely really informal. I just want to quickly go through a few concepts just to kind of get you guys understanding or back up to full speed. And so that's what these videos are going to be for. If you struggled with some of the physical science stuff that we had talked about earlier, this will be a really nice reminder of everything that we talked about in the earlier sections of the course. So earlier when we were looking at the mole, we said that the mole itself, it wasn't really anything special. We just said that the mole is just simply a number. And when we were talking earlier about Avogadro's number, we said that a mole is also equal to 6.02 times 10 to the power of 23 things. And so when we were talking with the mole, we said, okay, well, the mole is just a number. We need some way of quantifying that. We need some way of describing that. A mole is really nice for us because a mole of elephants, very simply, is also equal to a mole of hydrogens, for example. And then if we're talking more specifically about what we're working on right now, a mole of hydrogens is also equal to a mole of carbons. And that can be a mole of anything. We know that 1 mole of one thing is going to always be equal to a mole of another thing. And so as such, it allows us to convert really nicely in between units. Now, fortunately for us, scientists have gone through and they have looked at all of the values of the periodic table. And what we see on the periodic table, is if we look at carbon here, this value that I've circled here in red, this 12.01, that is what's known as the molar mass. The other term that you might see is the atomic weight. So either one of those two terms is accurate in terms of describing what that 12.01 number is. And what that number is that is the mass of a mole, or 6.02 times 10 to the 23 carbons. So we know that a mole of carbon has a mass in grams of 12.01. And so what we can then use to describe that is we can say that 1 mole of carbon is equal to 12.01 grams. Now, in class, I went over a really stupid example, and you might have thought that I was being kind of ridiculous. I asked you what some of these fractions were equal to. I asked you what 7 over 7 was equal to, and you told me that that was equal to 1. I would have asked you what 103 over 103 is equal to. You would have also told me that that's equal to 1. And you know those two things from your grade 7 or grade 8 math of interpreting fractions, knowing that one thing divided by another thing, or if the numerator and denominator are the same numbers, that fraction must be equal to 1. Now what's interesting is you can also rewrite this statement here as 103 is equal to 103. And when we do that, it starts to look very similar to this top example here, saying that, well, this statement here, these two things are equal to each other. When I put one thing over the other, that's equal to 1. And so as such, what we can do then is we can take this and we can say that we have 12.01 grams over 1 mole, and that should be grams of carbon. And we would know then that this fraction also must be equal to 1. Now I can also write the inverse, I can also write the inverse of this and say that 1 mole over 12.01 grams of carbon, we know that that is equal to 1. We know that both of those statements are equal to 1 because 1 mole and 12.01 grams of carbon are the exact same values which was told to us on the periodic table by scientists that are a lot smarter than myself. And so that's how we know what these mole values are here. We can convert between a gram of something to a mole of something. The other interesting thing that happens with moles is that as we're working through units, we want to be able to cancel units off. So if I had 1 kilometer per hour, let's say, for example, let's clear this up a little bit. If I was talking about 1 kilometer per hour and I wanted to figure out how many meters per hour I was traveling, well, in grade 10, what you would have done is we'd have said that for every 1 kilometer, there's 1,000 meters. So we did the time sign line here, and what we have now is a scenario where our unit is both on the top and bottom of the fraction. And up here with the 7 and the 103, what we said was that if anything is on the top and the bottom of a fraction, we said, well, we know that those must cancel out or equal 1. So our units of kilometers end up canceling out, and the only unit that I haven't canceled out that I have left is meters on the top and hours on the bottom. And you would have known then by going 1 times 1,000 here that we would have been traveling 1,000 meters per hour. And that makes sense because we knew that 1 kilometer is equal to 1,000 meters. So if I'm traveling 1 kilometer per hour, well, if 1 kilometer is equal to 1,000 meters, then I'd be traveling 1,000 meters per hour. And where that comes into play and becomes a little bit more applicable for us here, where that becomes a little bit more applicable to us, is when we start looking at converting between units. So let's say that I gave you 7 grams of carbon. I don't know how I would hand that to you, but let's say I handed you 7 grams of carbon here. And you wanted to figure out, okay, how many moles of carbon do I actually have? Well, we would always start these questions off with time sign straight line. And what we would want to do is go back up to this scenario here, where we had the 12.01 grams of carbon over 1 mole, and that was equal to 1. Or we want to take 1 mole divided by 12.01 grams of carbon, that was also equal to 1. The ideal scenario that we want to have here is we want to take this second option, because what that will allow us to do is have a gram on top of our multiplication problem and also a gram on the bottom. So exactly similar to this kilometers per hour example. So we want to be able to write this second statement as such. We want to write 12.01 grams of carbon on the bottom is equal to 1 mole. And now what's kind of confusing for some people is some people would say, okay, well, we've changed the number, so we have actually multiplied by some random thing. How can we do that? Remember, we said that this fraction itself here is equal to 1. So all we've done is take this 7 grams of carbon and multiplied by 1. Now the reason that the actual numerical values will change is because we are using different units. Because we have to convert between different units, even though this fraction is equal to 1, our numerical answer that we get over here will be slightly different. And so if we were to do this question here, we would say 7, we'd want to take 7 divided by 12.01. We want to take 7 divided by 12.01, and we would find out that you have 0.582. Or 0.583 if we round correctly. 583. And now the last question that we're asked is, okay, what are the actual units that we're left with? Well, if we look at this multiplication problem, I have a gram on top of my fraction. I also have a gram on the bottom of my fraction, so those must cancel out. And all I'm left with then is this mole unit. And we need to describe what type of mole is, because remember, we said that moles could be anything. A mole could be an elephant, it could be a rhinoceros, it could be a carbon. And so we need to specify that this answer would be 0.583 moles of carbon. So very simply, that's how you go from grams into moles, and we talked about some background as well, what the mole actually is, why it's relevant to us. Hopefully that's helpful with reviewing where we were at before we hit this quarantine break. Enjoy the video, and hope this was helpful.